I'm gonna solve the problem 1313, which is find the acceleration of titanium, the largest moon of Uranus, and its density. What do we know? We know that the radius of titanium is 1/8 of the radius of Earth. The mass of titanium is 1/1700 of the mass of Earth. And we know for theory that the mass of Earth is equal to 5.97 times 10 to the 24 kilograms, as well as the radius of the Earth is 6.38 times 10 to the negative 6 meters, plus the gravitational universal constant, which is 6.67 times 10 to the negative 11. The formula we're gonna use is gonna be the acceleration due to gravity of titanium is gonna be equal to g, this constant, times mass of titanium over the radius of titanium square. And then for density, we're gonna apply that density of titanium is gonna be equal to the mass of titanium over the volume of titanium. We know that titanium is an sphere, so we're gonna have to apply the formula of the volume of the sphere, which is equal to 4/3 pi r to the third. So for the question A, to find the gravitation acceleration of titanium, we need to find first what is the radius of titanium, which is equal to 1/8 of the radius of Earth, which is equal to 6.38 times 10 to the negative 6, and this is equal to 7.98 times 10 to the 5 meters. And then the mass of titanium is going to be 1/1700 the mass of Earth, which is 5.97 times 10 to the 24 kilograms, and this is equal to 3.51 times 10 to the 21 kilograms for titanium. Then we apply this formula. G of T, which is a gravitational acceleration of titanium, is going to be G times mass of titanium over radius of titanium square, and this is equal to 6.67 times 10 to the negative 11 times the mass of titanium, which is finding over here, which is 3.51 times 10 to the 21 over the radius of titanium square, which is finding as well, which is 798 times 10 to the 5 square. And this is going to be equal of G of T to 0.37 meters per second square. Then for the part B, there's asking you for find the density of titanium, which is going to be density of titanium is equal to mass of titanium, which is equal 1/1700 the mass of Earth, divided by 4/3 pi times 1/8 r of air to the third power. Just applying the formula of the sphere accordingly. This is going to give us 1/1700 times 5.97 times 10 to the 24 over 4/3 of the pi times 1/8 of the radius of air, which is 6.38 times 10 to the 6. And plugging this all in the calculator, you're gonna end up with 1700 kilograms over meters cubed, which is the density of titanium, and this is the last answer to the problem. Thank you.